Hello everyone. In this video, we're gonna talk about continuity of a function, a simple guide to understanding continuous and discontinuous function. By the way, I am Sweet Siren M. Elirin from BSFT 2M1. So let's start with what is continuity of a function. Continuity of a function means that the function does not have any abrupt changes, jumps, or hole in its graph. Or in simple words, a function is continuous if it can be drawn in the paper without lifting the pen. Okay? Now let's talk about continuity at a point. A function f is said to be continuous if the following three conditions are satisfied. First, f of c is defined. Second, limit f of x as x approaches to c exist. And third, limit f of x as x approaches to c is equals to f of c. Take note of this. Now let's talk about continuity of an interval. A function f is said to be continuous on an open interval a and b if it is continuous at each point in the interval. A function that is continuous on the entire real number line is continuous everywhere. And lastly, if one of the three conditions fail to hold, then we say that the function f is said to have a discontinuity at x equals c. So let's have a further discussion about this. So we have here a graph. So it appears that continuity at x equals c can be destroyed by any one of the following conditions. So in this first graph, the f of c is not defined. So the function is not defined at x equals c. This is a removable discontinuity. Second, the limit of f of x does not exist at x equals c. So this is a non-removable discontinuity. And lastly, the limit of f of x exists at x equals c, but it is not equal to f of c. So this is a removable discontinuity. So let's have an example for you to understand more about this. So example number 1. F of x is equals to 1 plus x if x is less than or equal to 1, and x if x is greater than 1. Remember the three conditions? First is the f of c is defined. Let us define f of c. So in finding this f of c, we need to look for an equal sign. So as you can see, we have here less than or equal. So this is gonna be our c. So that would be f of 1. Therefore, it is 1 plus x. Alright? So just put the value of x in here. So that would be 1 plus 1. And that will be equal to 2. Second condition. F of x exists. We have here two types of limit, the right hand limit and the left hand limit. So first, let us do the left hand limit. So the function of the left hand limit is, as you can see in here, this is a 1 negative. So we will gonna find the function that is less than 1 in here. So this is the less than. So therefore, this is gonna be the function. And that will be limit 1 plus x as x approaches to 1 negative. Next is to substitute the value of x, which is 1. So it will become 1 plus 1. And it will be equal to 2. Now we are done with the left hand limit. Now let us proceed to the right hand limit. So as you can see here, our x approaches to 1 positive. Which function has a greater than 1? So as you can see here, this is x is greater than 1. So therefore, this is gonna be our function. And that will become limit x as x approaches to 1 positive. So just put the value of x and that will become 1. So therefore, 2 is not equal to 1. So as you can see in here, our 2 is not equal to 1. Therefore, we can conclude, since the limit f of x as x approaches to 1 negative is not equal to limit f of x as x approaches to 1 positive, the limit f of x as x approaches to 1 does not exist. Hence, the function f of x is discontinuous and it is essential. So, always remember that if in the step 2 or in f of x exists part, if this is not equal, we will stop and we can conclude like this. Alright? Because again, remember here in this does not exist, that is a non-removable discontinuity. So we should stop. Okay, let's have another example. Okay, so we have here f of x is equals to 2x minus 1 if x is less than 1, and 2 if x is equals to 1, and lastly x if x is greater than 1. First step is the f of c is defined. Let us find our c, which is always look for an equal sign, which is this. So that will become f of 1 equals 2, since this is its function. Since we already defined the f of c, let us proceed to the step 2, which is the f of x exists. So we have here the two types of limit. So let us proceed first for the left. As you can see, our x is approaches to 1 negative. So we will find here the less than. So in here, we have x is less than 1. So this is gonna be its function, 2x minus 1. So it will become limit 2x minus 1 as x approaches to 1 negative. And then just input the value of x, which will become 2 times 1 minus 1. And then if we put it in a calculator, it will become 1. So now we are done with the left hand limit. Let us proceed to right hand limit. So we have again here our x is approaching to 1 positive, and that will be x is greater than 1. So this is our x greater than 1. So this is its function, x. So that will become limit x as x approaches to 1 positive. Again, just substitute our value of x, which is equals to 1, and then as you can see in here, our 1 is equals to 1. So we can conclude that since the limit f of x as x approaches to 1 negative is equals to limit f of x as x approaching to 1 positive, the limit f of x as x approaches to 1 exists. So since the f of x exists, we can proceed to the condition number 3, which is limit f of x as x approaching to 1 is equals to f of c. Just input the result of the existing f of x, which is 1, and then the defined f of c, which is 2, which means 1 is not equal to 2. So what we're gonna do is we can conclude, hence function f of x is not equals to f of c, therefore it is discontinuous and removable. So if we redefine the f of 1 equals 1, then the limit f of x as x approaching to 1 is equals to f of 1, and the function became continuous. So I hope you understand that. So let's have another last example. So f of x is equals to 3x minus 2 if x is less than 3, and x to the power of 4 minus 74 if x is greater than or equal to 3. So first step is to f of c is defined. So our c here is 3 because we have here the equal sign. And our function is x to the power of 4 minus 74. And then just substitute our 3 since the value of x is 3. So that will become 3 to the power of 4 minus 74. And then if we put it in calculator, it will become 7. So since we are already done in defining our f of c, let us proceed to the step 2, which is the f of x exists. So again, let us start in the left-hand limit, which is the limit f of x as x approaching to 3 negative. So 3 negative, that means a less than 3. So we have here x less than 3 and its function is 3x minus 2. So that will become limit 3x minus 2 as x approaches to 3 negative. And then just substitute the x with 3. So that will become 3 times 3 minus 2. So 3 times 3 is 9. And then minus 2 will become 7. So we're done with the left-hand limit. Let us proceed to the right-hand limit. So limit f of x as x approaches to 3 positive. So I'll always look for a greater than sign, which is this. X is greater than or equal to 3. So its function is going to be x to the power of 4 minus 74, and that will become limit of x to the power of 4 minus 74, and that as x approaches to 3 positive. And then again, just substitute our x, and that will become 3 so 4 minus 74. And if we put it in calculator, it will become 7. So as you can see, 7 is equals to 7. So we can conclude that since the limit f of x as x approaches to 3 negative is equal to limit f of x as x approaches to 3 positive, then the limit f of x as x approaches to 3 exists. We can proceed with the step 3, which is the limit f of x as x approaches to 3 is equals to f of c. So just input the f of x result, which is 7, and then the defined f of c, which is also 7. So as you can see, 7 is equals to 7. Therefore, we can conclude that the function is continuous. So that's all, and thank you for listening.